Hello, and today we're going to learn about conductors and insulators. And today I've got some different conductors here. You see the yellow one, the orange one, the white with the blue stripe, and this here is a category 5 cable that is cut. And there's a bunch of conductors inside. But when I say conductors, we're just looking at the outside, and that happens to be the insulation. So this yellow plastic, this orange plastic, this white and blue plastic, this blue plastic, and all the plastic that's on the conductors inside, that's all insulation. So now what is a conductor and what is an insulator? Well, a conductor is a material that allows electrical current to flow easily. But an insulator is a material that does not allow electrical current to flow easily. So we could say that an insulator is a non-conductor. They are opposites. And I'm going to demonstrate with my multimeter here, which I have set to the ohms range. And right now it's showing OL, which means it's over the limit of what this meter can read right now. So right now we're measuring between these two leads the resistance of air, and it's over the limit of what we're reading, and we're introducing a new concept. It's measuring right now in megohms. So right now the air is more than 100 megohms. That's all we know. It could be a higher resistance, but it's beyond the range of measurement of this multimeter. And now we're going to demonstrate through a conductor. So conductors usually are metal, and in this case all of these wires are copper wires, and so we're going to demonstrate what the resistance is of a conductor. And so I'm going to hook up my alligator clips, which are connected to my multimeter leads, and then we'll put that down there, and then you see it's 0.0 ohms. So the copper conductor is a very good conductor of electricity, and it's telling me that it's got 0 ohms resistance between the two. So I'll take that out and we'll check the next. Now this orange wire here, this is a pre-made terminal wire, and it's got a copper conductor under the insulator, and then it's got ends that are crimped on, which is very handy for the type of work we're going to do later with solderless breadboards. So it's got a solid pin that looks chrome plated that will go into the solderless breadboard to make our connections. So this is a very handy type of jumper wire, but it does cost money to buy these pre-made ones, and it's a little cheaper. You can make your own by buying a spool of wire, and then you have to strip the insulation off the ends to make a jumper wire like this one and like this one, where the insulation is stripped off the end. And an insulator is plastic, so I've shown copper. So let's measure the resistance across plastic. So there you see it across a plastic insulator. Again, it's OL, it's over the limit. So again, our reading is more than 100 megohms for this insulator. And it will be the same when we test the insulator of any of these wires. The outside insulation is going to be a very high resistance. So again, you see we're getting this OL, which means again the insulation is more than 100 megohms. That means it's a non-conductor, it's an insulator. And why do we want an insulator? Well, that's so we can make sure that our current flows where we want it to. Because if we have a circuit with many wires, if we have a circuit with many wires just like this, if these were all bare copper, well, they'd all be shorted together and we wouldn't get our individual circuits or signals that we want to go through it. They'd all short together. So in order to get our electric current going on the path that we want to, we have to insulate it from the other conductors. So insulation is also very important, and conductors are very important. And some of the conductors that we have available to use is copper, and I recommend copper wire, and sometimes there's also aluminum wire. But aluminum wire is not so common in use, but in some applications it is, because aluminum currently is cheaper to buy than copper. But for our projects I recommend to always use copper wire. And what other metals? Like there's iron and steel and chrome and silver and gold. Those all conduct electricity fairly well. But copper is the best conductor for our hobby purposes. And you can find copper wires from an electronic hobby store and from electrical stores. But we have to make sure for our hobby purposes, for low current circuits, we're using the right size. So this wire here is a 24 American wire gauge, and that's about the smallest that we'd want to use with our experimenter sockets. And this one, the pre-made terminal ends are 22 gauge, and that's about the ideal size of wire for the hobbyist for our experimental circuit boards, solderless breadboards. And this one is 20 gauge, so that's a little bit too heavy to use in our experimental solderless socket boards. So that's the end of our presentation on conductors and insulators.